So, what if I told you that warp propulsion is no longer just a concept from science fiction? Asking you guys to imagine a future where spaceships travel at the speed of light is insane. But please bear with us for the sake of this video, because scientists are giving everything they've got this 2025, and they have now uncovered a groundbreaking method that could enable travel at speeds 10 times faster than light. The possibilities this unlocks for the future are, in simple terms, out of this world. Well, I assume we all remember the Concorde, a supersonic passenger jet that once cut travel time between Paris and New York to just 3.5 hours, was a revolutionary feat in aviation history. But today, supersonic speeds are mostly reserved for fighter jets, while commercial aviation has slowed down. As humanity pushes further into space, we face a major challenge. Distances between stars are vast, and without faster-than-light travel, journeys to even the nearest star system would take thousands of years. For the longest time, physics seemed to impose an unbreakable speed limit, making it impossible for any object with mass to reach the speed of light. Einstein's theories of general and special relativity dictate that nothing can surpass the speed of light. As an object approaches this limit, energy requirements skyrocket to infinity, making such speeds unattainable. Scientists have spent decades searching for a way around this barrier, and now a breakthrough may be on the horizon, bending time and space itself to create a faster-than-light spaceship. If you're a fan of sci-fi movies, you're likely familiar with the concept of a warp drive. Spaceships accelerate for a brief moment before vanishing into a glowing burst of energy, reappearing in a distant part of the universe in an instant. What was once fiction may now be within reach. Initially popularized by sci-fi legends like John W. Campbell and Star Trek creator Gene Roddenberry, the concept of warp drive gradually evolved from fictional storytelling to serious scientific exploration in the 1990s. Einstein's equations suggest that any object with mass would require infinite energy to reach the speed of light. However, scientists have proposed an alternative, bypassing the need for propulsion by manipulating space-time itself. Rather than accelerating through space conventionally, this approach involves distorting space-time, compressing it ahead of the spacecraft and expanding it behind, allowing the vessel to slip through with minimal resistance. This method doesn't contradict Einstein's theories, but rather works within their framework. The primary challenges: producing the immense energy required to bend space and developing the technology to make this feasible. In 1994, physicist Miguel Alcubierre introduced a theoretical solution while working on his doctorate at the University of Wales. Using Einstein's equations, he outlined a framework that, in theory, could enable faster-than-light travel while adhering to the known laws of physics. The biggest hurdle is practical implementation. Relativity dictates that as objects accelerate, their mass increases, making it exponentially harder to push them to the speed of light. Only massless particles like photons can travel at such extreme speeds. However, the Alcubierre warp drive offers a potential workaround. The principle behind it is relatively easy to grasp even for non-experts. By locally expanding space-time behind the spacecraft and contracting it in front, the ship would appear to move faster than light to an outside observer. Meanwhile, those inside the warped region wouldn't experience much change. Perhaps they'd see light stretching behind them, stars racing past, or feel a slight vibration. Within moments, a spaceship using this warp mechanism could traverse vast cosmic distances, effectively achieving faster-than-light travel. The Alcubierre drive operates by expending an enormous amount of energy to bend and fold space-time around the spacecraft, forming a self-contained bubble. This bubble acts as an inertial frame, preventing the occupants from experiencing traditional acceleration forces. Nonetheless, the fundamental laws of physics remain intact, both inside and outside the bubble. Within this framework, matter could effectively exceed light speed, not through conventional thrust as seen in vehicles, aircraft, or space probes, but by altering the structure of space itself. One common misconception is treating the universe as a singular, fixed space. However, relativity describes space-time as a flexible fabric that any mass can distort. The gravitational effects we experience arise from this curvature of space-time present everywhere in the universe. In fact, you're subtly bending space-time right now just by sitting at your computer or holding your smartphone. This naturally raises an intriguing question. Could a human manipulate space-time consciously, contract space ahead of them, and emerge elsewhere in the cosmos? Theoretically, it's possible. Practically, however, achieving such a feat would require an extraordinary amount of force, far beyond what the human body or current technology can generate. The Alcubierre drive would require an energy source powerful enough to sustain the space-time bubble and propel it forward. This is where we face a major obstacle. Whether using diesel, gasoline, hydrogen, or methane, current energy sources fall drastically short. Based on what we know, we'd need an energy output equivalent to the mass of Jupiter, an astronomical amount, to make warp travel feasible with existing technology. In the meantime, however, a potential solution to this challenge has been proposed: negative matter. This theoretical exotic substance, which is believed to possess negative mass or energy density, is considered a promising key to unlocking warp travel. However, there's a significant issue. Negative matter remains purely hypothetical. It has never been observed or confirmed to exist. While its existence is suspected based on certain theoretical models, no concrete evidence has been found. This presents a fundamental problem. How can we design a propulsion system based on something that might not even be real? And even if we were to discover negative matter, another major hurdle would be gathering or producing enough of it to power a spacecraft. Yet where there is a challenge, scientists remain determined to find a solution. Warp drive remains an enticing concept, and researchers continue their pursuit because ultimately the need for faster-than-light travel is undeniable. Before exploring the most recent and potentially viable approach to warp propulsion, let's take a moment to assess the current state of human space travel. Be warned, this might be disheartening for those dreaming of interstellar adventures. The speed of light is an unbreakable physical constant, approximately 300,000 kilometers per second. In science fiction, iconic starships like the Enterprise transport their crews at warp speeds, theoretically reaching up to 9,000 times the speed of light. In reality, however, our fastest spacecraft are astonishingly slow by comparison. Space probes, despite being relatively small, require enormous thrust to reach distant planets such as Jupiter, Saturn, or Venus. The Juno probe, which studied Jupiter between 1995 and 2003, traveled at a peak speed of 74 kilometers per second, merely 0.0002 times the speed of light. Meanwhile, Voyager 1, which has been traveling for nearly 35 years, only recently exited the solar system, now located over 21 billion kilometers from Earth. The fastest human-made spacecraft to date is the Parker Solar Probe, which reached speeds of 191 kilometers per second near the Sun. Yet, even at this velocity, our current technology barely allows us to venture beyond our cosmic doorstep. Compared to the vastness of space, even relatively short distances present enormous challenges. Given these limitations, space probes must rely on carefully calculated acceleration maneuvers, using the gravitational pull of planets to gain momentum. Many probes take complex orbital routes, circling Earth and Venus multiple times, or leveraging Jupiter's gravity to gradually reach their destinations over several years. To put this into perspective, imagine a friend from the Proxima Centauri system invites you over for coffee. With today's technology, your journey would require looping around several planets just to escape the solar system. by which point you'd likely never make it in time. Not even close. As things stand today, a journey to our closest cosmic neighbor would take over 100,000 years. Clearly, at this pace, humanity isn't making meaningful progress in space travel. If we ever hope to become an interstellar civilization, groundbreaking new technologies are essential. Fortunately, advancements in warp technology are continuously evolving. Dr. Eric Lenz from the University of Göttingen has recently introduced a revolutionary approach to warp drive, one that eliminates the traditional challenges of requiring negative matter and vast amounts of energy. In his research, Dr. Lenz proposes that achieving light-speed travel could be possible using known physical principles that can be practically applied. The key lies in solitons, more commonly referred to as warp bubbles. Unlike previous theories, this concept relies solely on positive energy densities that are already well understood. However, while this idea marks a significant breakthrough, there is still a long way to go before it can be realized in practice. Even as researchers in Dresden were exploring these possibilities, another astonishing discovery emerged. Dr. Harold "Sonny" White, a former NASA scientist, has identified an actual warp bubble. Though his primary research at NASA focused on evaluating the feasibility of warp technology, his breakthrough came while studying an entirely different phenomenon, the Casimir cavity. This effect occurs between two metal plates placed extremely close together, where microscopic structures resembling natural warp bubbles are observed. Currently, the Defense Advanced Research Projects Agency, DARPA, is funding further studies in this field. The challenge now is to replicate these small-scale structures on a much larger scale. If scientists succeed, the first real warp drive and the dawn of interstellar travel may be within reach. Become a subscriber now to never miss an incredible video.